Good day, guys, and welcome to Internet Academy. So, today, still on physics, we're going to talk about universal gravitation. We know that gravity is what the force that tends to what bring an object back to what the surface of the earth, and of course, we're seeing universal. That means it's more of like the gravity in the universe. We're not considering only the earth, we're considering the earth and other planets and the solar system in full. So the concept is easy. Gravitation was first observed by Isaac Newton. He noticed that what object that has mass attract other object that has mass, and he went further to notice that what the force that force increases as what the mass of the object increases. So for massive objects, the force of gravity is much. Then he also noticed that what the force of gravity reduces as what the distance of separation between those two masses increases. So, of course, he just suggested the law and he stated the law in two ways. You have an object of M1 and an object of what? M2. And we see that R is what? The distance of separation between two of them. He stated that the force of attraction between mass 1 and mass 2 is what? Directly proportional to what? The product of their masses. Let's also say that if the masses increase, the force of attraction between two of them will increase. And I told you later, so let's call this equation 1. And he gave another suggestion that this force of attraction will reduce as what? The square of the radius increases. So those are the two speculations. First is what? The force of attraction between these two masses will increase if what? Their masses increase. For massive objects, the force of attraction will be bigger. And take note, the second suggestion is that the force will reduce as what? The radius increases. Which is, when you hear of radius, it's not only the radius, it's the distance of separation between the two mass. So the force will reduce if this increases. Let's just say that, for example, if we have another object here, and let's ignore this object, and we have another object here, we have M3, the force of attraction between M1 and M2 will be greater than the force of attraction between M1 and M3 because of the distance of separation is far, right? So that's the concept. Of course, when you combine this equation, which is 1 and 2, you notice that what the force of attraction between these two masses is direct proportional to what the product of the masses and what indirect proportional to what the square of what the distance of separation between two of them. Of course, in a case where you have a proportionality sign, for us to get rid of the proportionality sign, we introduce what? A constant. And that constant is known as what? Universal gravitational constant. So you're having a case where it becomes F is equal to what? G M1 M2 over what? R square. So take note, M1 is what? Mass of the body. M2 is another mass, and R is what? Distance of separation between them. And take note, G is what? Gravitational constant. Which experimentally it is found to be what? 6.67 times 10 raised to power negative 11 Newton meter square per kilogram square. So of course, this is a concept. You can make use of dimensional analysis to check the unit of the value of the gravitational constant. So that is the concept of what? Gravitation. Of course, we have a question here, and the question says determine the force of attraction, which is F, between a physics student of mass 70 kg and the Earth's separated by a distance of 6.3 times 10 raised to the power 8 meters. So if you take the mass of the earth as what? 5.972 times 10 raised to the power 24 kilogram. And we should take G, of course, the value of G here is on the board. So of course the concept is easy. We have a question. Of course, we write our given parameters. Of course, what are we given in this question? So we are given the mass of the student, the physics student. So let's call the mass of the physics student mass M1. Of course, is 70 kg. And if we look here, we're given, of course, the mass of the earth. So let's do it. The mass of the earth, of course, equal to what? 5.92. Okay, 972, right? 5.972 multiplied by 10 raised to the power 24 kilograms. The distance of separation between those two masses, the mass of the earth and the mass of the physics student, to give distance of separation between them as 6.38 times 10 raised to the power 8 meters, and of course even G as what? 6.67 times 10 raised to the power negative 11 Newton meter square per kilogram square. Of course, to calculate the force of attraction, in this case, we are having, of course, the force of gravity is what? G M1 ME over what? R square. Of course, we are having F 6.67 times 10 raised to the power what? Negative 11 multiplied by the mass of this physics student 70 kg multiplied by the mass of the earth 5.972 multiplied by 10 raised to the power what? 24 all over what? Of course, the distance of separation, which is 6.38 multiplied by 10 raised to the power 8 all squared. Of course, let's punch this and let's see the value of the force of attraction between these two. So we have the force of attraction between the physics student and the mass of the earth is what? 0.0685 Newton. So this is the concept, and this is how we calculate the force of attraction between two objects. In this case, one of the objects is earth and the other object is a physics student. Of course, I'm a physics student, so that's it. Let's solve some problems. Let's solve more problems, right? Of course, we have another question here, and they said we should calculate what? The force of the Earth's gravity on a spacecraft 1000, okay, I think it's 12,800 kilometers, which is in more brackets 2 Earth radii above the Earth's surface if its mass is what? 1350 kilogram. Calculate what? The force of the Earth's gravity on a spacecraft, which is 12,800 kilometers above the Earth's surface, if its mass, which is the mass of the craft, is 1350 kilogram. Of course, for to solve this problem, we have solution. Of course, they have given us a lot of information. They have given us the mass of the craft is what? 1000, of course, 350 kg. Of course, from here we know the mass of the earth. That's the mass of the earth is what? Of course, from that question, 5.972 times 10 to the power 24 kilogram. It's very important that in some cases, some questions will not give you the mass of the earth. It is assumed that you should know the mass of the earth. Of course, they have given us the distance of separation. Of course, they give us 2 radii of the earth. If you look there, you see 2 radii, 2 earth radii, or radii of earth. So you should know that, of course, we are given the radius of the earth in this question. 2 times what? 6.38 times 10 to the power what? 8 meters. You're seeing that from the question now, we are given 12,800 kilometers, which is equivalent to what? 12800. Of course, 3 zeros represent the kilometers. If you multiply this, you see that this is close to this. but the assumption is 2 Earth radii. In the case where they didn't give you 12,800 kilometers and they give you 2 Earth radii, you should understand the concept, right? That 2 times the radius of the Earth. That's what 2 Earth radii is. Is that understood? So it's a very easy concept. With all these parameters now, you should know that. You should know what G is. A constant, a gravitational constant. So it's one of the things you should know. The first things you should know is that this value is what? 6.67 times 10⁻⁻11. So with all those things now, we can go on to calculate the force of attraction. Of course, the question is a very tricky question from this concept. But if you understand this, you're good to go. And let me explain further about this question. Is the force of attraction between the spacecraft and what? The mass of the Earth. Of course, I told you earlier that gravity is a force that tends to pull an object down towards the surface of that Earth. So therefore, for you to operate above the Earth's surface, gravity must have an effect on you. Even though you're in space, gravity must have an effect on you. So the concept is it will tend to bring the body down. There's still gravity effect. And the distance of separation is the 2 Earth radii. So you can understand the concept, right? Let's go on. So, of course, we have G, mass of the craft, mass of the Earth over what? The square of what? The distance of separation. So you have that F is equal to what? 6.67 times 10 to the power -11 multiplied by what? 1,350 multiplied by the mass of the Earth, which is 5.972 times 10 to the power what? 24 all over what? Bracket of what? 12,800, of course. Then the kilo represents what? This 30 represents kilo. I hope you understand. Kilo is 10 raised to the power 1000 or 10 raised to the power 3. So these 3 zeros result from the kilo. So of course multiply of, we can use us, we can just add the 100, the 1000, right? Of course square. So if we punch this correctly using our calculator, so let's punch this correctly using our calculator. So we have a case where we have 6.67 times 10 to the power -11 multiplied by the mass of the Earth, the mass of the spacecraft. Yeah, so we have the mass of the craft, which is 1350 multiplied by the mass of the Earth. Very massive. Of course, 12,800. Then the 3 zeros, 1, 2, 3. Of course, square that value, and you will notice that what? The value of what? The force of attraction is what? 3,282.15 newtons. So this is the force of attraction between the spacecraft and the mass of the Earth.